Hey guys, I'm going to do a couple more examples of composite figures. This is just part 2. I'm just going to do one example here, and then for my part 3 I'll do another example very similar to what you see in your homework. So this one you're going to see something very similar to this in your homework as well. I'll just change a few numbers around here and there, but the concepts still apply. So what we're going to do is we're going to take a look at composite figures and try to see if we can recognize any shapes in this composite figure. Now the composite figure here, this has 1, 2, 3, 4, 5, 6 sides. And it's not regular, it's irregular. So it's not like a 6-sided polygon where all the sides have the exact same measurement. Okay, it almost looks like a circle, right? But you got a lot of different signs. It's kind of like a stop sign, but that has 8 sides. So this is same thing, same concept. But what we have to do is, in order to find the area of something like this, you have to break it into the shapes that you recognize, and you have to look at how do we solve the area for each of the shapes that we recognize. Now, if you look here, hopefully you've noticed this small shape here is a parallelogram. Okay, so I'm going to write that down. Parallelogram. And remember, a parallelogram, the opposite sides are parallel. Okay, they're never going to touch each other. If you continue on throughout eternity on this plane, right, on this flat surface, those two lines, if we would continue on, they would never touch each other, kind of like railroad tracks, sort of. Now, if you recall, the area of a parallelogram, area equals base times height. And the height, this is not the height here. The height's going to be strictly up and down. That's what this 90-degree box down here means. It means it goes up and down. It's perpendicular to the base. It means it's straight up and down. So we take the formula. That's the very first thing you want to write down for any shape, is the formula for it. So for parallelogram, it's base times height. The base is 6. The height is 5. And you're done. So it's just 6 times 5. And then once you figure that out, you've got the area for this little parallelogram right here off to the side. Okay, so you should see something like that in your homework. Now, trapezoid. This is what this shape is. This is called a trapezoid. A trapezoid has 2 bases. Okay? You've got base 1 and you've got base 2. And if I didn't have base 2, let's say, and I'm not going to mark this off, but let's say that this was kind of like a rectangle, right? I didn't have this little piece right down here. If that's all this was, this would be pretty simple. It would be just 7 times 10, and this would be 70 inches squared. Okay? But it's not. It's got 2 bases. Instead of 7 times 10, or even 9 times 10, because 9 times 10 would also be too much. 9 times 10 would look like this. So it's not 70 inches squared, and it's not 90 inches squared. It's somewhere in between. Okay? And I forgot to put inches squared over here, by the way. I forget stuff like that sometimes. Okay. So instead of doing a big picture analysis and trying to explain exactly why the formula is the way that it is, and even explaining why my formula is better, I'm not going to go into that. But the formula for a trapezoid is area equals 1/2 of base 1 plus base 2 times height. And sometimes you won't see that little dot there. It means times. Okay, sometimes you'll see it right up against the parentheses. You always want to start with the formula, because that will help you structure the problem. And then what you do is you plug in what you know to find out what you don't know. So again, we don't know the area, but we know the bases. We have those numbers, and we have the height. So we're just going to plug in what we know. So area equals 1/2 is going to stay because that's part of your formula. 1/2 of base 1 plus base 2 times height. Okay? And then we just simply follow order of operations. Please excuse my dear Aunt Sally. Parentheses first. No exponents. We're going to multiply. Okay? You've got this 1/2 here, right? This is actually means multiplication here as well. Now we don't see a little dot here, but you could put one there. But when you have a number next to another number and this one is in parentheses, it basically means multiplication. That's really what it means. So instead of actually multiplying it out, I'm going to write it down again just to show you the step-by-step process. All right, so 1/2 of 16 times 10. So what is 1/2 of 16? What's 1/2 times 16? It's 8, right? Because 1/2 of any number is just basically dividing it by 2. So this is 8. 8 times 10 is what? 80. 80 inches squared. Now, if you recall earlier, I said if we had cut this off, if this was simply a 7 by 10, this would be 70. And if I had gone with the 9 instead of the 7, this whole thing here would have been 90 inches squared. Did you notice that this number is in between 70 inches squared and 90 inches squared? That's what happens. With the trapezoid, you can actually find the area with one of the bases, then find the area again with the other base, and then find the middle number. That's another way that you could do that. Okay. So basically, all you're going to do is just add up your areas. You got this is 30 inches squared here, and this area is 80 inches squared. So what you need to do is you need to combine those. 30 plus 80 is 110 inches squared. So that's going to be your total area. And that's important because a lot of times you'll see things like this. It'll be feet. Like you could have a kitchen that maybe the floor design is in this shape. You see this a lot in life. It may not be something that you would see now, being as most of you are very young and not in the flooring or tiling business. But you will notice this in a lot of different shapes and surfaces. Okay, so hopefully that helps. We'll keep working. I'll give you another example, another trapezoid with a rectangle taken out of it. Okay, that'll be part 3. All right, guys. God bless. Talk to you later. Bye-bye.